Welcome to this whistle-stop tour on AWS services. We are specifically going to be looking at AWS from a development perspective. Now, I've been doing AWS for quite solidly for the past few months, going through the foundational and then the associate architect, the solutions architect exam. And I'm just coming to the end of the AWS for developers, and I've started to consolidate the services that I found useful, especially when I'm building mobile or web apps. So this is what we're going to be looking at today. This is the agenda. We're going to be looking at various services. We're not going to be covering absolutely everything, and there's some stuff that I missed off here that I do intend on actually covering in the future, such as how VPCs, subnets, CDK, these sorts of services. But right now I feel these are the most important ones to get you up and going anyways, that is. But you will have to have an understanding of VPCs and subnets and the different types of security groups and how they work. But yeah, let's continue on. So the first one we're going to be looking at in terms of the services is S3. So what is S3? Well, S3 is essentially Cloud Object Store, and you can think of this as a folder on your desktop that just has many different subfolders. But in the context of AWS and S3 specifically, the terminology that is actually used is buckets. So files are stored in buckets, and a bucket is just basically a big box where you can store objects. So you can replicate the notion of having a folder and files inside, but I don't think that was the intention when S3 was created, because there is different services for that. So there's different file services that you can actually use throughout AWS, but S3 is one that's critically important. And I think, I could be wrong, I do believe it's the biggest service. I could be wrong on that. It could be EC2, but yeah, I would imagine it's S3 just based on the amount of data that gets stored in there. And S3 is so flexible, you can put anything you want in there. You can, launch a static website. You can go ahead and store a bunch of log information, analytics data. Then you can set this as a hybrid, whether you be on-prem or you're using some sort of solution that is using some on-prem data that gets synced up to S3, or whether you're just specifically using a cloud architecture. And there's many different architectures you could use. You could have on-premises, and then you could have a hybrid where you're using some on-prem stuff, but you're also using some cloud architecture. And then you could also be using AWS, but you could also be using Azure as well. So there's many different architectures, but I want to keep this as simple as possible. One thing you will find in S3 is that there's a bunch of different storage classes, and it can be quite confusing at first, especially if you're looking at the exams and planning on taking these, or just using S3 as this, a simple service. But one thing you do want to be mindful of is, how the storage classes actually work, and it's something we're going to be touching on shortly. AWS actually do, really push the high availability aspect of S3, and that's why every object at minimum is stored in free availability zones. And you'll see these referenced mainly as AZs, especially when you're in the presence of someone who works in cloud architecture, or alternatively you're doing some research online. You'll generally see AZs, and it's better to have AZs. I've just done it myself. It's better to have multiple availability zones because you can actually have redundancy in place, which is really good. So what do I mean by AZs? Well, you could have some, let's look at the UK. You could have multiple availability zones within the UK. So this gives you the durability and availability just in case one of those availability zones goes down, and you could use a fallback. And that's one of the beautiful things about S3. Every object, as mentioned here, is stored in 3 availability zones. So that provides 99.9999999, and maybe another 2 nines durability and availability of objects throughout the course of a year. So I definitely think it's a service that is highly available. It's probably the most available in terms of services throughout S3, depending on your architecture, that is. So yeah, as mentioned, think of it, if you are brand new to S3, of just like a a place you can store folders and files. But essentially what you are doing is you're using containers, which are buckets for objects. And one thing to mention here before we go on to the next slide is that a unique name must be used to identify your buckets. So if you go on there and try use a name that's very generic, more than likely it's going to be taken. So try use a unique name for your buckets to identify your resources. Lastly, one thing that is really useful as well is version control. So version control exists within S3. I believe you have to turn this on because I think it's a paid service. I could be wrong there, but I generally turn this on if I'm doing like static websites, so that if I happen to, release a new version of a page and it turns out to be, crap, or there's errors, or there's bugs, or there's been an instance where, let's say, for example, we released a page and we've accidentally broken one of the main functionality components on that page. We do want to roll that back as soon as possible, and having versioning on S3 really helps with that. So do keep that in mind depending on what you are storing. But we can take a look more now at the diagram that's provided to us by AWS. So you see here there's an ample amount of opportunities that it is open to you to store in an S3 bucket. So you've got analytics data, log files, application data, videos and pictures, backup and archival. So it says here, move your data to Amazon S3 from anywhere it lives in the cloud, in application, or on-prem. Now, when it comes to building applications, I try to not put anything really in terms of data in the application itself. So I do try to store that, whether it be in a file server somewhere or in S3. And the majority of the time now I'm just chucking it in S3 because it's so easy to use. It's so easy to create a bucket. You can specify the region. You can put access controls on there. So if there's multiple people within your organization, you can modify the access and the permissions. Therefore, you can give someone, I wouldn't say admin access as such, but you can mess around with the controls, and you can set bucket-specific policies for certain people to say, yeah, they can view this. If they want to delete this, they're going to have to use multi-factor authentication. Nice implementations like that. So it's really, really useful. And as mentioned here, it is a huge service. Therefore, the storage is in 3AZs, and you can store and retrieve from pretty much anywhere. You can control the access to the data very easily. Replication of data is very easy. And I think I talked about this just previously, but accessing the data, whether you're on-prem or you're using VPC. I imagine, let's say you have an EC2 instance within a VPC, and it's in a private subnet. You would want to allow access maybe just out to the S3 bucket, or whether you're doing updates, for example, you want to allow access out to the internet then, but you don't want to have any inbound traffic. But I think that's a bit out of scope for this video. But I will be doing a follow-up on VPCs and subnets and public and private subnets and how they work. So I feel like the information online is fairly convoluted, and hopefully I can simplify that. But yeah, basically it's just a place to store stuff. That is S3. And then, if we're following the diagram, you can pass that data over to different AWS services, and then that can analyze your data to gain certain insights, whether that be analytical, machine learning, AI. And you can also, I believe, run SQL-based queries in S3, which is really nice. So moving on to storage classes. Now, there is a bunch of different storage classes, and it's really important that we do understand how these work. Now, you may, I guess if it's the first time using S3, you may just want to go ahead and just use like the standard, the frequently accessed data. And if we just touch on that point, what does it mean if it's frequently accessed? Well, it goes back to, you have to make a decision when you're, kind of planning out the architecture of your application. How often is that data accessed? How often do you want to retrieve that data? These are the types of questions you should be asking. If it's data that's, often accessed, let's say it's some images, videos, and they're on a website, then you could probably get away with the standard storage class. The intelligent tiering is a quite interesting one because it can change the storage class based on data patterns. So if, for example, if you put some data in there, you don't touch it after like 7, 14, 21 days, depending on the configuration, it could potentially move that data to a different storage class, and therefore it can save you less money. Well, it can save you money, more money that is. Now you've got standard IA as well. So this is standard IA, and it's basically just the same as standard, but it's for the absolute opposite. So for data that isn't accessed, every so often, but you still want to retrieve that data almost instantly. And you'll see that there's a pattern here where there's millisecond access across all the storage classes, apart from the Glacier DA, and that's one we're going to touch on. If you haven't come across the Glacier Deep Archive, this will be an interesting, topic to touch on once we've gone over the other storage classes. The one zone IA, you'll see that only has one availability zone, and that is, recreatable, less access data. So what does that mean? It basically means data that you don't really care about that much. Maybe what you're doing is you're maybe doing some, let's say you're doing some AI related work and you're generating a bunch of pictures for a user who uploads like 5 or 10 pictures. Now, I would imagine you'd delete those pictures, but you want to do some processing on them so that you can analyze them and you can maybe modify the background, maybe make them look a bit more cartoonish. And once you've done all that work, you can go ahead and just remove that data. So it does give you millisecond access, but it's for data you don't really care about too much. And if it got lost, you wouldn't care that much. Now, the final two here, we have Glacier IR and FR. Now, the first one is instant retrieval, and it's ideal for archival data that needs immediate access. Now, that's the distinction here. If you want immediate access, but you have, data such as medical images, news media assets, or user-generated content archives, it's where you want to store a bunch of data, but you don't really care about. I wouldn't specifically say not getting it within like a few seconds or milliseconds like the other ones have. But let me rephrase that. If you have such data as medical images, user media assets, and if we touch on medical images where a patient comes in and you have to pull out that data, but it's not been used for like 7 or 14 days or even 14 weeks, it's still archived in a way that you can get it back immediately. But the only point I would like to touch on here to show the distinction between all the different storage classes is that there's a minimum storage duration. So this, for me, Glacier IR, which is instant retrieval, is quite ideal if you are doing stuff with data that you don't need to be, using all the time, but you need it for a long time. So I'm not talking days or weeks here, I'm talking like years. So medical data is one that I could that briefly came to mind, and then news media assets, where if you want to go back and look at a telegraph from 10 years ago, you can get it instantly, but there is a minimum storage duration. Whereas if we look at S3, you'll see here I've got the IR/FR. If we look at the FR, which is the flexible retrieval, now this can pretty much, it does pretty much the same, but this here is an instant access. This is ranging from minutes to hours, but you do get, let's say you're pulling out a bunch of different information and you're trying to retrieve a bulk amount. Now, it's free, and this is ideal for like backup, disaster recovery, offsite data storage needs. And I guess when let me think of an example. When data occasionally needs to be retrieved in minutes but not instantly, and you don't want to worry about cost too much. And again, just touching on this point here, you have to think about the architecture of your application prior to actually choosing one of these storage classes, because it's really important to just think, okay, well, do I need standard? Do I need frequently accessed data? If so, potentially standard is for you. If you don't know, put it in intelligent tiering, and you'll get to a point where you kind of understand your data patterns, and it'd be really good to get like some sort of analysis after like 30 days, for example, and then you can move your data about in the storage classes. Now, if we touch on Glacier DA, which is Deep Archive, now this is the lowest cost storage class, I believe, and it supports long-term retention and digital preservation for data that may be accessed. And here's what you've got to keep in mind: for once or twice in a year. So for example here, this could be healthcare again, this could be financial, it could be public sector, it could be news, it could be database records where, well, I wouldn't say database records actually, because in S3 you wouldn't be storing database records as such, but you would want, I guess, object-based data, and that is, key value. Yeah, and you can store JSON data in there if you wish, but data basically that's been accessed once or twice in a year. So like I did mention, financial services, healthcare, public sector, news, and in here, this is really ideal as well for like businesses that need to keep accounting records for like 5 to 7 years or 7 to 10 years. And some of this as well, if you're working with like public, in the public sector, let's say the NHS, I'm sure that for X amount of years, you will have to keep documents around, and it doesn't make sense to be storing them on physical paper these days, especially because there's no redundancy involved. I think I've covered all the storage classes here. There's one to mention as well, which is S3 on Outpost, which delivers object storage to your on-prem network. So as I mentioned it 2 or 3 times now, we can use S3 on-prem. So if you want or are interested in doing so, look at Outposts. It's another service that allows you to, deliver your object store basically. So your buckets and everything else that's involved in your tiered architecture for storage and data. So yeah, AWS Outposts, take a look at that. The next one I want to touch on is, let's see on the agenda, EC2. So this one is a very, very popular one as well. So I'm not going to touch too much on this, I just want to touch on the different aspects of instance types. But if you haven't come across EC2, it's basically where that you can, get a computer in the cloud in a matter of seconds. I know that's on the slide here, but it's a really important statement. There's no need these days to be using low-profile web hosts and web hosts that don't give you redundancy or high availability. If you want an EC2 instance, it's very easy to just spin one up in a region or across multiple availability zones. And with AWS, there's physical locations where you can spin up your instances, and you can attach all sorts to them if you wish. EBS volumes. You can start looking at instance stores. You can configure by CPU, memory, network, storage, and you can have a really low-powered instance, or you can have a really high-powered instance, depending on what you're doing. If you're doing some AI, you're doing some analytical processing. Again, it just goes back to what you're doing with your app, but you can pretty much get any sort of configuration. And if a configuration isn't there for you, you can also spin up a fleet of instances, which is really nice, where you can have multiple instances working on the same, app, if you wish. Now, EC2 instances, you do get pre-configured ones. These are known as AMIs, Amazon Machine Images. So you can have a look at the OS, you can have a look at the software that's pre-installed, and you can also create your own AMIs, which is really useful. So if you have an instance, let's say, that many people are working off from within an organization, you can create an AMI with pre-installed OS, pre-installed patches, pre-installed software, all that sort of stuff. So it's really useful. And these are very easy to replicate as well. So next up is the storage and VPC. So storage volumes for temporary data that's deleted when you stop. So some of the things you have to, the gotchas of using an EC2 instance, and you eventually get used to this sort of stuff, but you can have an instance store. So like, for example, you can have a virtual network where what you can basically create that is logically isolated from the rest of the AWS cloud. And this goes back to, if you're using a VPC, you can put you can put a EC2 instance within a private subnet, and you can isolate that EC2 instance. You can, then do whatever you need to do in that EC2 instance, but it has no outbound access to the internet. You can have maybe inbound if you wish. You can stop that as well. But what I tend to do with these instances in a private subnet is I allowed outbound access, but only for certain patches and software updates. And I don't allow inbound if I'm doing something that I want to isolate. I will allow inbound from other services, but I will lock that down with IAM rules and permissions. But yeah, when you're working with VPCs, definitely take a look at like here, storage volumes for temporary data that's deleted when you stop. You want to look at either hibernating or terminating your instance. If you hibernate your instance, you can, I think, retain that data on the storage volume. And then when it comes to stopping or fully terminating that instance, you have like a small instance store that's attached. Now, if you terminate the instance, I believe that's gone. If you just hibernate it, it should still be around. And I believe that is the RAM where that particular data is stored on. And lastly, the high availability. So you can have multiple locations for your resources, such as instances and EBS volumes, which we will touch. And again, you would plan this around your architecture. So if you have multiple availability zones, which I always tend to do, have at least 2 or 3. I think that's a fairly good setup to go with if you are planning on having high availability. So moving on, let's take a look at some of the instance types. So we have on-demand, reserved, savings plans, spot instances. And these are the core ones that I really tend to use or tend to sway more towards. So on demand, you basically pay for what you use by the second, and you have like a minimum of 60 seconds, but there's no commitment. You're not paying no contract, you're not paying no upfront payment. There's no head to terms to say, oh, I'm going to use this and you pay as X. I do X, you pay as Y. There's none of that. It's just really flexible, and that's what's really nice. So if you are using an EC2 instance for like, I don't know, let's say a few weeks, definitely take a look at on-demand instances. Now, the reserved instances, so you can reserve an EC2 instance, right? And you can also look at the savings plan or reserved instances. We're going to touch on them both here. But the thing with reserved instances is we can cut the cost down. We can have the exact same spec as the on-demand instance, but we can reserve for a term of 1 or 3 years. Now, reserved instances enable us to basically allocate a slot to a certain amount of compute power, and we pay in advance. So if we say we want 16 gigabytes, this is a CPU of RAM, this is a CPU we want. Now we pay in advance for that compute power. And if we just look over to the left on savings plans, it seems very similar. Like we can reduce our AWS costs by making a commitment to amount of usage. So the difference here is a savings plan, you are looking at a commitment to a consistent amount of usage for a term of 1 or 3 years. And it says here, reserved instances is based on specific instance configuration. So we have savings plans and reserved instances. Now, depending if you're wanting compute power that you know that is not going to change, go with reserved instances. If you need a commitment to amount of usage, so I'm going to use this EC2 instance for this amount of time, go with the savings plan. And you can save a really good amount. I think you can save up to 75%. Now, reserved instances are a tricky one because I don't know, a year or 3, you will tend to, I guess, change like the configuration. And I guess if you don't use that certain configuration, or I think with savings plan, you can sell this on the open market and you make some money back. But yeah, just be careful, because with a reserved instance, if you book out an EC2 instance in a specific region for 3 years to a specific instance configuration, are you sure you're going to need that compute power for 3 years? Stuff changes. And hopefully, as the business grows or whatever platform you are working on, you would want, to expand. Now, if you have a development or testing environment, it really depends which one you want to look at here. It depends on the usage too. If you're doing like a 9.5, you may want to look at you could look at reserved instances for a year to say, yeah, we're not going to really go past this in the test environment. This is a specific instance configuration that we want for our test environment. You could look at reserved instances. Now, savings plans, this I would probably look to if I had a production environment, because it's a consistent amount of usage, and you can get a good chunk of savings if you go for a term of 1 or 3 years. And if you have a production environment, it's unlikely that it's going to be the same amount of traffic for the next 1 or 3 years. So I would look towards usage as opposed to reserved instances. Now, lastly, spot instances. Now, you can request unused EC2 instances at a specific, I guess, cost to reduce the overall costs. Now, spot instances are a funny one because they can be pretty much taken at any time. And actually, we've got a slide here that I forgot I put together. But the thing with spot instances is they are well suited for data analytics or analysis, batch jobs, background processing, operational tasks. Good for to using batch jobs alongside SQS, and we'll touch on SQS, but it's for data that is, I guess, processable but also retrievable. So if you're doing like 10,000 messages and you want to batch process them on a spot instance, if you do like 2,000 and then that instance gets shuts off, and then you've already sent another 200 to the instance and now they're no longer in the queue. Now you can get around that. You can start holding or creating a dead letter queue, so you can actually put the messages back into the queue. So the spot instance can save you money, but you just have to be careful because they can be shut off at I guess any time, or if someone outbids you. I haven't used them that much, but like I did mention here, it could work for development environments, but I think on demand or potentially reserved instance might be better, to be honest. I did mention here, like for dev environments, maybe on demand's better. But if you have a dev environment and you're a functioning company who's been around and you expect to be around in 1 to 3 years, go ahead and save yourself some money and start looking at savings plans or reserved instances. But here for on-demand instances, they are well suited for applications with short-term, irregular workloads that cannot be interrupted. Dev/test environments. Now, that doesn't mean you're going to have like a website that's on there over the course of a year. You could just have a dev test environment for, spinning up a container and testing if you're a small team. It really depends on the use case. But if I was to have a dev or test environment that I knew would be around in a year or 3 years' time, I would look to savings or reserved instances. Now, a savings plan is ideal for a production environment because you get like you're basically specifying your usage. So a year of usage with a flexibility to change course at any time. And the flexibility word here is key. If you're a functioning and growing business, you need that flexibility to be able to change course at any time. And I think that's why savings plans might work better for such as a production environment. Now, reserved instance. This is good for steady and predictable usage. So suited for always on compute power. So if you're processing, let's say a queue of messages that is being processed, I guess, by SQS at a certain point, but it's being pushed over to the EC2 instance, and it's steady. It's the same amount every day. Maybe consider a reserved instance in that sense. And there's many more here as well. There's not just like these particular types. There's other ways to save money on EC2 instances. So definitely check them out. Let's move on and I guess look at some of the different instance types. So we've got general purpose, compute optimized, memory optimized, accelerated computing, storage optimized, and HPC optimized, so high performance computing. So these are some of the instance types. I'm not going to specifically go into each, and I believe I've maybe missed 1 or 2 off here because I don't think they're important in the eyes of I guess in the context of this presentation, but these are some of the instance types. Go ahead, check them out. I am pretty much just using 0 and 1 at the minute here. I haven't looked to use HPC, so for high performance computing. My storage optimized, I generally go and use something that's specific to storage. But so my favorite, moving on, Lambdas, serverless computing. So we can run code. And I've been using it a lot with JavaScript without thinking about servers or clusters. So it's truly serverless in the essence that we can upload a script, whether that be some sort of Slack bot, that can be some sort of message processing application. It can be potentially a gateway to authentication. There's an ample amount of opportunities to use Lambdas. So I mentioned here, if EC2 is a complete computer in the cloud, Lambda is a code runner in the cloud. So that's pretty much what a Lambda is. And I believe there's a max timeout of 15 minutes on the Lambda. And I really like pairing Lambdas with some sort of queue. So And I'm banging on about queues quite a lot, but that's what I've been working on quite a bit recently, where I'll have maybe I'm using EventBridge, and EventBridge is processing a cron job at a certain time. It goes and fires off to the Lambda that handles the data that's coming in, and then it can go ahead and make API calls. So it's really, really good. So with EC2, you get an operating system, a file system, access to the server's hardware. But with Lambdas, you basically upload the code and Amazon runs it for you. And it's really useful. And like I said, I have specifically been looking at JavaScript, but I think you can use .NET, Python, and there's a bunch of other opportunities in there. One of the things that you may have to be flexible on is like the Node version if you are using JavaScript. I don't believe they've got every specific Node version. It would be good if you could specify every Node version imaginable, but I'm sure a time will come where you can use something like a Node version manager in there. And there is a decent amount of Node versions in there, but the last time I checked, there wasn't the one I was wanting to work with at the time. So yeah, lastly, I guess on Lambdas, from a high level, is that they're more suitable for small snippets of code that rarely change. I've got, I think, 2 or 3 Lambdas running at the minute for an application I'm building, and they very rarely change. But I do like the fact that you can use Lambdas. You can hook it up to CloudWatch. You can process a bunch of logs. You can even look at CloudTrail, so you can start looking at what invoked a Lambda, what sort of events happened. There's a bunch of stuff you can do with Lambdas, and I think they are core to the development experience, and that's probably why they're touched on quite heavily on the AWS Associate Developer exam. So, features of serverless architecture. So you probably do hear this term thrown around quite a lot, especially in the context of AWS, where you're using compute and serverless, and what the hell does any of this mean? So with a Lambda, we can automatically respond, I guess, to maybe events that are coming in, and then we can then process them using the Lambda. So the Lambda is the execution, and the Lambdas can scale ridiculously. So we can process so many different events per day to hundreds of thousands per second. And you know what's great about Lambdas? They don't cost that much. I've been running on Lambda, and it's cost me 2p for the month, and it's been used daily. So definitely check out Lambdas if you are wanting to go down more the serverless route as opposed to spinning up EC2 instances left, right, and center. If you have a simple application, split it off to a Lambda. You can start looking at layers or frames, I think they are, within a Lambda. And then, just making it a budgeting call at that sense. Can we turn this small processing application into a Lambda? If so, you can save yourself a bunch of money. With a Lambda, you only pay for pretty much the time you use, so by millisecond, as opposed to when you're doing an EC2 instance, you are provisioning infrastructure, and you are using an operating system on there. I think you'll have to have a hypervisor. So there's an upfront cost for peak, I guess, capacity. So if we start looking at things like Fargate or ECS, where we are spinning up EC2 instances easily, it starts adding up. So just be careful when you are spinning up EC2 instances. They can get quite costly if you've got a large amount of traffic. So lastly here, we can optimize code execution time and performance with the right function memory size. So respond to high demand in double-digit milliseconds with provision concurrency. So when you do actually configure your Lambda, this is the sort of stuff you can actually look at. So you can look at the timeout. I can't remember, but I was working on Lambda the other day and it had a timeout of 3 seconds. Now I don't know if that's the default or I accidentally set it, but it was throwing some errors because I was retrieving data from DynamoDB, which we'll touch on a bit later. So I had to up that to 60 seconds, but I think the max, as I did mention previously, is 15 minutes on the Lambda, which is quite a long time actually for code execution. So yeah, optimize code execution and performance with the right memory function. So just make sure you configure your Lambda correctly and play around with it. Next up, we are just going to look at, I guess, a small diagram as to how web apps fall into the nature, how Lambdas fall into nature with web apps now. Not everybody's using them. There's many people still running highly successful websites where they're not using Lambdas, but it is good to see this diagram where, let's say for example, someone uploads some code to an S3 bucket. User clicks to get that information, and then we go to the API gateway where the app makes a REST API call to an endpoint. Now, in between this, you can see it be going over the network, and then let's say the Lambda gets triggered. Now, the Lambda runs the code to retrieve this local weather information. So we can either get that from Dynamo or another source, and then we can return that back to the user if need be. In this instance here, you'll see that DynamoDB is on the right. So this is where all the weather information is contained. At the most simplest fraction of the line, I would say that if a user clicks on local weather information, it hits API gateway, hits the Lambda, it goes to Dynamo, spins back round, traverses it, puts it on the user screen. That's how I would imagine that would be set up. And you'll see far to the left, static website is hosted on S3. So this is the type of like architecture you want to build a web app in. Statically build these apps, use an API gateway that's hitting your backend services. You know, you don't have to use an API gateway. If you want to use GraphQL, spin up an EC2 instance, use GraphQL. But I do recommend looking at S3, API gateway, Lambdas, DynamoDB. These are very simple and highly available services. Okay, so next up, we've got a few more slides actually. We're going to be looking at elastic load balancing. So what is elastic load balancing? Well, it's essentially just distributing the user traffic, or let's say application traffic, in a way that doesn't crash your app. So there's a few versions, and haven't listed them all, but I want to point you to the most important ones in my eyes, and the ones that are most useful anyways. So if you're using a web app, or I don't know, you've got some sort of application set up, more than likely you want to look to an application load balancer. This operates on the OSI model at layer 7. So this can route your traffic to EC2 instances, IP addresses, Lambda functions. Really, really useful. And there's a bunch of stuff you can do in there in terms of configuration, what we will look at. But when you see this, either in the exam or you've got a question around building your web application, if you are distributing and using HTTP and HTTPS traffic, application load balancer on layer 7 is what you probably will need. Now, if you're doing TCP and UDP traffic, which is on layer 4 of the OSI model, look for a network load balancer. So again, you can use EC2 instances, microservices, containers, all this stuff. But let's say, for example, it's a multiplayer game, it's running on layer 4. Well, it's not running on layer 4, but it's interacting with layer 4. You want to look at like a network load balancer. Now, the gateway load balancer, this is one that's fairly hard to understand actually, but enables you to deploy, I guess, an array of, well, I wouldn't even say an array of, but it does allow you to scale many virtual applications, firewalls, intrusion detection, and prevention systems, and deep packet inspection systems, which operates at layer 3. If you don't know the OSI model, go ahead and take a look. Look into like layer 3, 2, and 1, and how as you go up the layers, you can avoid collisions. I think at layer 1 and layer 2, this is where, I think maybe layer 1 is where collisions happen, and that's why layer 2 came, and then layer 3, you start looking at frames, I believe. But it's been a while since I did computer science, so I could be wrong on that. Okay, so this is the one that I guess I have most knowledge of in terms of the ones that I was talking about. So there is a diagram here. I'm not really going to touch on absolutely everything. I'm just going to talk over my use cases of using an application load balancer. And I did mention there's a bunch of nice features that you can use. So it does say a few here: redirects, fixed response, user auth, login, health checks, sticky sessions, load balancing algorithms, content-based routing. So if someone's in a certain region, you can send them to the load balancer. The load balancer will then go to maybe an S3 bucket that targets people who are Spanish or French, from Argentina, or I don't know, my geography is terrible, but you can imagine you can do geographic routing through the load balancer, which is really, really nice. You've got your health checks in there, you've got your sticky sessions, You can also do weighted routing, which is really nice. I think you can also do it on Route 53 as well. But sticky sessions, now I haven't used these in a few years, but it's basically a mechanism that routes requests from the same client to the same target. Now, what does that mean? So if you have 10 EC2 instances spun up using ECS or Fargate, and let's say we're tracking a user on instance 6, they click off, they come back, it's going to route them back to instance 6. And the way it does that, is by using a cookie. So, application load balancers support both duration-based cookies and application-based cookies, which is really useful. And I can't quite remember what cookie it sets as the identifier, but I think it's X Amazon Trace ID. Maybe that's not cookie attribute, but the header on all incoming requests to the load balancer. So if you Google X Amazon Trace ID, it will probably give you more of a definition on how it works than I can. But it's essentially a HTTP header on all requests that are coming into the load balancer. So request tracing is crucial here. If you want to trace requests, such as by, a unique ID, it makes it really easy to do this across, various different services. So it's really useful. But yeah, sticky sessions, it basically just drops a cookie. What else have I used application load balancers for in incoming requests? You can do HTTP to HTTPS requests, which is fairly normal these days. So going from port 80 to port 443, that's useful. You can use Lambda functions as targets. That's pretty good too. So you can register Lambda functions as targets for the load balancer, and then you can maybe support content-based routing rules to different Lambda functions. So if you've got two different Lambda functions based on the content that the user is eventually going to see, it's probably worth looking into an ALB for that. I'm trying to rack my mind for other things. I guess the ALB will give you an array of different key values too, so like path URL, HTTP header, method, query string, source IP. If you want to redirect, say, 80% of people to an EC2 instance, but 20% of people to an S3 bucket, you can do that as well with a routed policy. There's even a WYSIWYG in there. You can use a WYSIWYG. Is it a WYSIWYG? I'm not too sure, but there's a visual diagram builder that you can actually use where you can specify traffic allocation, which is quite nice. But I would prefer if this was done in files, which we'll look at a bit later. You can do path-based routing too, which is really, really good. So you can route a user based on a request in the URL. So if someone requests something in any URL, you can set up a distribution to say, go to this particular S3 bucket, or go to this EC2 instance, or go to this Lambda. You can also do HTTP header-based routing, which is really good. So you can route a client based on a value that they either set in the header or we've set it somewhere for them. So it's really useful because I sometimes like to check production deployments that aren't live to the user yet on a versioned EC2 instance by specifying a header value. And it allows me to bypass and get to that EC2 instance because I've got a header value set, and I can go through the ALB for that. Then you've got HTTP method-based routing, so you can route a client based on custom HTTP methods or metrics. And then, of course, query-based routing, that goes without saying. And then the next one we're going to look at is the NLB, which is a network load balancer. Now, I did touch on this one, and this does operate at layer 4, so TCP and UDP. And an NLB cannot assure availability of the application, right, like an ALB can. This is, and it's simply because it bases decisions basically on the layer 4. And it says here, network load balancer layer 4, UDP, TCP connection based, source IP, preservation, low latency. So if you want low latency, but you aren't looking for the availability of the application, and NLB is what you need to look for. Now, because it's on layer 4, TCP layer variables basically has no awareness of the application at all. None. So generally, when you're using an NLB, we need to determine, well, it's going to determine the availability based on the ability of the server to respond to such a request, such as a ping, or to complete a handshake. There's a freeware TCP handshake, which is really useful if you don't understand that. It takes me back to my computer science days. If you go look up the TCP handshake, it's a freeware handshake. If you can't get that connection or can't correctly complete, you are fairly screwed. So an ALB does go much deeper, is capable of determining availability based on HTTP GET, for example. If it's doing a health check and it's sending back, 500, or it's just getting no HTTP response whatsoever, something's really messed up. And bear in mind, you probably will get HTTP response, whether it's 200, 418. If anyone understands the 418, drop it in the comments. 500. But the ALB, if we're touching on the ALB, which is one back, layer 7, it does go much deeper, and it's capable of determining availability of the application. And not only for a successful HTTP GET of a particular page that we may be referencing, but also verification that the content is as we expect based on the input parameters. So there's quite a few differences here. So you do want to just pay attention to the differences for your use case. Lastly, GLB. So a gateway load balancer operates at the third layer of the open system interconnection OSI model. I should have probably called that out earlier. So OSI model is the open systems interconnection model. And it's basically showing all the different layers of the network. It's really interesting if you're interested in networking, so definitely check it out. And it basically, if we're talking about the layer 3 here for the gateway load balancer, it listens for all the IP packets across the ports and forwards the traffic to certain targets. So, as I did mention, we can auto-scale like custom firewalls, packet manipulators, inspectors, and gateway load balancers use, I can't quite remember the name, but I think it's endpoints to securely exchange traffic. So if you've got like two VPCs or VPC boundaries as such, a gateway load balancer endpoint, I guess, is a VPC endpoint to some extent, because then you're getting the private connectivity. So if you've got two VPCs, you get the private connectivity between the virtual applications. It's kind of, I guess, how VPCs work. VPCs, gateway load balancer, but you won't be using, I wouldn't imagine, half a dozen, or I don't know how many gateway load balancers you'd be using, to be honest. But for traffic to go to and from a GLB endpoint, you have to configure this in the route tables. Now, we haven't touched on route tables because it's a whole nother topic, and I'm going to cover route tables when I cover VPCs and subnets, public and private. But just be aware that there is more than just the ALB. We'll maybe touch a bit more on the gateway load balancer and how this works. But you'll see even from this image here, you've got the source internet workloads, you've got the ingress routing. So if you played with like Kubernetes, KH, you probably would have had to set up an ingress route and route tables. So you've got a few things that are similar to an ALB, such as sticky sessions, but long-lived TCP connections is an interesting one too. So that's it. So we've done application, network, and gateway load balancer, and next I want to take a look at ECS, ECR, and Fargate. These are some of my favorite services after Lambdas. But let's jump in and take a look at these. Basically, allows everyone to run the same instance or the same container, and you don't have to worry about setting up a node version. You don't have to worry about setting up a certain OS that it runs on. You can just do this within Docker, and it's very easy, right? Now, ECR is just a containerization service, so you can host all your containers on here. Really useful if you're using some of the code pipelines that AWS provide. It's really, really good for that as well, because it basically allows you to not have to use something like Docker where you got to use a paid service. And I do believe, maybe I'm wrong, but you can use application images and artifacts on here. Maybe it's free. I can't quite remember, but it might be. If not, it's definitely cheaper than Docker, I would say. So yeah, ECS, it basically eliminates the need, right, for you to install, operate, and scale your own cluster management infrastructure. So if you've worked with Kubernetes, it's a pain in the ass to deal with doing this, right? And with ECS, it basically allows you to do like simple API calls, because that's all AWS is. It's just API calls for doing stuff. And you can launch and stop containers very easily. And we can query the state of the container for the cluster. We can access, many features such as security groups that I'm going to touch on in a future video, elastic load balancing, which we just looked at, elastic block storage, IAM. There's a bunch of stuff that can integrate within ECS, and it's really, really useful. Now, you can go down the route of using ECS with EC2, but this is why we're going to look at Fargate, because I'm far too lazy to be doing that. You can use ECS to schedule container placements across your cluster based on your resource needs and your availability requirements. So let's say, for example, you get high amount of traffic. You can, potentially schedule the containers, the placement to go in certain instances based on requirements and traffic that you require. So you can integrate your own scheduler if you wish, or you can do it based on business or application specific requirements. ECR, we pretty much know how that works. It's just a place to store our Docker containers. I think the majority of people I've worked with use Docker. And then Fargate, we're going to be touching on that versus ECS, because people do ask the question, why use ECS over Fargate? Now, that's not the question to ask, and we'll look at that why shortly. But Fargate is just a serverless compute engine for containers. So if we put together ECS and Fargate, or just ECS in general, we can say, okay, well, if we hit 50% CPU on these instances, scale, give me more EC2 instances so I can handle all this incoming traffic. Now, Fargate manages the task execution. So there's no EC2 instances to manage, which is fantastic, because you don't want to be managing EC2 instances. It's a pain, it's time consuming, costly, it's not worth it. So Fargate, you want to pay for your running tasks. That's it. It's easy to launch. Works with EKS, which is the Elastic Kubernetes Service, and it works with ECS. Now, just going back on that question, why use ECS over Fargate? And I did mention it's not the question to ask, but people will ask it. So ECS is responsible for managing the life cycle and the placement of tasks. So a task is usually made up of one or two containers that work together. Let's think, okay, we have a front-end app, and that's getting a large amount of traffic, and the CPU is going to 90%. It's maxing out. The traffic is getting to a point where the website is becoming very slow. We can't host this in a reasonable manner where all users can get a great experience. So we can ask ECS to start or stop a task, and we can store the intent, we can schedule the intent, we can look at scaling policies, and specifically, I wouldn't say this is ECS because you can do this with EC2 instances, but we can start looking at many different ways to be able to control our containers. So ECS only provides the control plane. Now again, if you've used Kubernetes, you'll have some sort of control plane to manage the tasks. But who's running the containers? So to run the containers, you have two options basically. You can use ECS container instances, or you can use Fargate. And this is what I really want to drill into your heads. It's not ECS versus Fargate, it's ECS and Fargate, which is generally the two I put together and layer them. So both are fantastic. Both can, work in an isolated manner if you wish to do that. An ECS container is nothing more than an EC2 instance that runs on the ECS container agent. That's it. That's all ECS is doing. So the EC2 instance is owned and managed by you, but hold up, here comes Fargate. So Fargate manages the task execution, right? So we do not have to manage the EC2 instances anymore. Done. We don't have to do that, which is great because it's a pain. Costly, as mentioned. So we pay for running the tasks. That's it. It's easy as it sounds. Pay for running the EC2 instances. Let Fargate manage all this stuff. And then each task that runs in Fargate comes with a dedicated Elastic Network interface. This does come up on the exam, the ENI. And you will get a private IP address. Likewise, with the majority of stuff that you get EC2 instances, you always have a private IP address. If you want a constant IP address, a static one, not a dynamic one that's changing, look at an elastic IP address. So all containers for the same task can communicate with each other via localhost, which is really nice. So inbound and outbound traffic communication goes through the ENI, the Elastic Network Interface. A public IP address can be enabled as well. So scaling container instances is a challenge. Just use Fargate. That's what I would say for Fargate. You don't have to worry about scaling all these EC2 instances that are essentially, if you're having to manage them, the less stuff you have to manage, the better. Is there anything else I want to touch on this ECS versus Fargate? I'm trying to think if there's anything I missed in terms of critical knowledge when to use these services. So the instance appear in a list of the instance. Maybe we touch on like the ECS container agent that I did mention. So how does that work? Well, it's basically just polling. That's all it's doing. It's just polling and checking if the ECS API, if there's new containers needed to be started or stopped, it basically looks at that. Let's say, for example, we've got an error on one of our containers. We can look at and get a notification or do whatever you want to do with that. But yeah, usually you'll just run like a cluster of container instances in an auto-scaling group, and that's generally what I like about this particular service. ECS is free. Again, you want to pay for the EC2 instances you're using. The downside is you have to scale, monitor, patch, and secure the EC2 instances yourself, especially since scaling is not easy, right? It's a pain, and that's why Fargate is your best friend. And there's no obvious way really to, I guess, manage the metrics or look at the ability to scale the cluster and the integrations for task placements. But yeah, definitely look into auto-scaling groups too, because the auto-scaling group that you may not come across now in ECS are not aware of each other. So making task deployments can be quite hard, especially when a cluster is scaling in or rolling updates. Using, I guess, a rolling update, or if you're using CloudFormation, say I now want 4 instances as opposed to 2. And you want to kind of do a rolling update so you can like scale up or down without actually killing or running tasks and causing a bad experience for the user. And I think that's it. But definitely look at these two. It's really good for high performance websites that are using EC2 instances and not having to manage them. Next up, we are going to look at CloudFormation. So CloudFormation is basically just infrastructure as code. You may have come across different variations of this. You may have looked at Terraform. CloudFormation itself runs JSON or YAML declarative code files. So you can specify in these JSON or YAML code files what you want to provision in the intended state. So if you want to spin up 8 instances, you can say this in here, 8 EC2 instances at this CPU, at this memory. When you are spinning these up, there's like a 1-to-1 memory to CPU that you should look at on AWS EA's documentation. You can't just specify, I want this amount of RAM and this amount of CPU. There's, I guess, tiers that you have to look for. So why do people do this? And it's all the new fad, isn't it? And it's been like this for the past few years, where we can deploy and update compute resources based on files, essentially. That's all it is. Well, it just makes it really useful. We can provision our infrastructure in a way that developers understand. If something goes wrong, we can just reuse that file. If we ever have to do a rollback, or let's say you've got a file that is specific to peak, which could be the Q4 Christmas time, and then you've got one just for the other 8 months of the year. So you can just provision it very easily. You can upload on AWS these files, so like the JSON or YAML file, and then you can do like rolling updates. So again, if you did want to go from 8 to 16 tasks, you can easily do that with CloudFormation. I haven't used Terraform that much, but it's very similar. And also do take a look at CDK, Cloud Development Kit. So the Cloud Development Kit, you can do it in the language that you understand. So if you don't understand JSON or you don't understand YAML, you can actually just define your cloud compute resources using a programming language that you're familiar with. It's really helpful. Trying to think anything else I have missed on CloudFormation. There's so many like services that it's hard to wrap your head around all these. So don't feel the need to understand absolutely everything. Make notes, check AWS's documentation, check other people's resources online, such as blogs and videos. And CloudFormation, yes, does support the underlying infrastructure such as VPCs, subnets, gateways, route tables, network ACLs, all that good stuff. Elastic IPs, anything you can imagine, basically. Security groups, autoscaling groups, elastic load balancers, RDS, tons and tons of stuff it supports, and it's really, really useful. You can pretty much manage your entire stack and manage the group of resources outlined in your JSON or YAML file, to basically get going. I mentioned stack. So stack set is a group of stacks you manage together and you can replicate in a group. You'll see these where you've got to basically kill the stack or do a rolling update on the stack, and they do take time. They can take up to 20 minutes sometimes from my experience. But yeah, check out CloudFormation, very, very useful. So next up, DynamoDB and Aurora. So the battle of the databases. So what is Aurora? Well, it's a fully managed relational database engine. So it does work with MySQL and Postgres, if you have used either of those. I have used MySQL more. But it is approximately 5 times faster than the standard MySQL database and 3 times faster than Postgres. Now, I haven't seen the actual underlying test for that, but I'll take AWS at their word. But the thing I do like about Aurora, as opposed to just using EC2 with MySQL installed, is like the high availability, the redundancy, the fault tolerance, self-healing storage system, the ability to create replicas. There's a bunch of stuff in Aurora that should persuade you to use Aurora over just a traditional MySQL setup. Now, Dynamo is a fully managed serverless key-value NoSQL database, and it's designed to run high-performance applications at any scale. It's very powerful, connects very well with Lambda. It's built-in security, continuous backups, multiple region replication, in-memory caching, data and export tools, and there's a ton of stuff. Not to mention streams as well. So if you haven't come across them, definitely look up DynamoDB streams. Aurora serverless too. That's, I guess, somewhat similar in the sense that you can create like a database, specify the desired compute capacity in a range, and then you can go ahead and connect your application. And there's many different ways, right? So if you're trying to have a highly scalable Aurora database, you'd probably want to be like, okay, the primary write access is this URL. Everyone who's writing is going to this. But for all the read access, we are going to replicate the reads. We're going to replicate the Aurora databases, shove them in different availability zones, potentially different regions, and modify your application to adjust to that specific URL to the database. So I always try to do that. I always try just write to, like, say, the primary instance, and all the replication instances are there just for reading. But yeah, very useful. Aurora and DynamoDB, two heavyweights of the database. What would you call it? The database contenders, or I don't know. You look on the screen here, we've got the producer who can send messages to the SQS queue. So I don't know why I say SQS queue. Simple queue, service queue. Okay, that's a bit redundant, but so SQS. And you've got a fully managed messaging queue service, which is reliable. So we want to touch here on reliability. So in what instances would you use this? Well, if you have a front end that is sending messages to a back end, so 2 separate EC2 instances, there could be a time where you go and send, let's say, an order to the back end, and the back end doesn't receive it. But everything else happens, so 90% of the workload happens, and you're at a point where you've got a bit of an unhappy user, right? Because they said the order has gone through, your system's saying it hasn't. So how do you fix this, like, for future reliability? And I guess just redundancy in a sense. If we can look at maybe implementing something in the middle of these two apps, and that would be SQS. So basically, the simple queue service lets you send, store, receive messages between, I guess, software applications. So the front end and the back end. And you can do this pretty much to any volume without losing messages or, requiring services to be available. Okay, so how do we do that? Well, with SQS, you can, use the producer, let's say it's the front end, to send to SQS, and then SQS will then go ahead and, process that to the consumer, which could be the back end. Now, what happens if the back end's down? Well, you can use something called a dead letter queue. And a dead letter queue is essentially just another queue that is there to collect events and messages that just don't get delivered for whatever reason, right? Let's say the app was down, something just happened that was unintentionally bad. So yeah, basically SQS, it lets you integrate and decouple distributed software systems. So if it's front end, back end is prime example, but there's instances where you might not even be using a front end or a back end, or you might just be using a Lambda, right? You could be doing what I was doing, where you're using EventBridge and then you're using SQS. Well, I wasn't using SQS directly, I was using a dead letter queue, which was function on SQS. But you can always inherit the functionality of the dead letter queue, regardless if you've got, let's say you're using EventBridge and you're processing things over to a Lambda. Sometimes there may be an error with processing. Validation could have not kicked in the way that you'd have liked it to happen. Let's say there was some uncharacteristic symbol or character that slipped through and broke the runtime, right? So now we can put that into a dead letter queue, which is functioning on SQS. Now, SQS is very helpful for, an array of different tasks. So like asynchronous processing. So we can process workflows asynchronously. We can process messages in parallel if we wish. We can use multiple SQS queues. We can decouple services, as I mentioned, where we can go ahead and split out or intersect, or actually, as opposed to intersect, I would say inject into the middle of two applications. So you've got the ability to decouple and create redundancy for the start to the end of the user journey, or just between these two apps, right? So you can store, send, receive events in reliable, guarantees pretty much. So ordering and processing. Now, you have the concept of the producer, which is here, and the producer is basically the component or person or persons that sends messages to the queue. Could be done through an API call, it could just be done by manually processing, it could be using a CLI, whatever it may be. There's an array of different ways to do it. It's, there's a multitude of avenues we can take to, get the title of the producer. A consumer is just another component that receives messages from the queue, basically. And there's two types of queues. The ones I generally use is, just the arbitrary ones where it's like, okay, I can throw a bunch of information into this queue, maximum throughput, best effort ordering, and at least one try delivery. Now, if you've got a comp sci background, you can have a FIFO queue. A FIFO queue is first in, first out. So it's designed and guaranteed that the messages are processed exactly once in the order that they're sent. Okay, so hopefully that makes sense for the SAS, the SQS. Moving on, SNS. Now, how do these differ? Well, SNS is a distributed publish and subscribe solution that is used for application to application. And it can also be application to person, because you'll see here, application SNS goes over to the email, or goes over to a Lambda. So SNS topics are used to enable communication, basically. That's what they're there for. So you can decouple message publishers from subscribers with topics. Again, we got here, you'll see a dead letter queue. So if an endpoint is unavailable, messages can be held in a dead letter queue for analysis or reprocessing. You can change how long it's in the dead letter queue for. Like, let's say, for example, you just want to hold, messages that haven't made it outside of the publication for 24 hours, then you can just remove them or delete them. But SNS topics are used essentially to enable communication. So we can decouple the message from the publisher, and then we can get it, and then we can, I guess, throughput to the topics for the subscribers. So publishers, I guess, publishers publish messages to topics. As you can see here on the left with the orange. Publisher, SNS topic. So we publish the messages to topics, and consumers subscribe to these topics to receive the messages. Right. So when this happens, you can deliver. I guess you can actually do that. Actually, now looking at the SNS. So if you're, I don't know, let's say, essentially with SNS, you can deliver messages to various different types of subscribers, right? And you can also do this, if you see at the top right, to SQS queues. You can do it to Lambda functions, HTTP endpoints. You can use SNS to send SMS messages if you wish, email, publish notifications to end user devices. There's a bunch of things you can do with SNS. And again, two types of topics essentially. We're going to go back to the one where it's best effort ordering, deduplication, and then first in, first out. Okay, so that was a lot for SNS. I'm trying to think of anything I've missed. So subscribers receive messages in subscribing serverless functions, queues, microservice, delivery, and more. So it's a publish subscription. So it's a pub sub input, if you are aware of that. It's almost like, I wouldn't say, if we compare to the SQS, you'll see here we have a producer who pushes to the SQS queue, blah, 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 with encryption, and consumers. So nearly infinite scalability and ability to increase message throughput to consumers without the need for pre-provision capability. And then if we look here, it differs quite a lot. You'll see we have the publisher, then you have SNS. So it's a fully managed pub sub messaging system, or service even. And then you have the dead letter queue, which is fairly standard if we compare it back to the SQS one, which is here. Doesn't say that specifically there, but you can hold them in a dead letter queue. And then message filtering and fan out filter messages according to subscription filter policies and deliver them to subscribers. So it's whoever is subscribing can receive this information. Whereas I believe with the SQS, I see here with the needed provision capacity, you are like pulling from the queue. So the consumer or consumers, let's say it's just one app, right? It's the back end. It's just pulling to see what's there in the queue. Whereas here it's a pub sub. So you are essentially, and there's quite a different set of, well, it's not quite a different set of things, but there's a lot of different things that you can do with SNS. But also SQS is very, very valuable as well. And you can see it can be used in the SNS too. And lastly, Cognito. If you haven't come across Cognito, you can basically add user sign up and sign in features and control access to your web and mobile applications. So it provides an identity store basically and federation options where you can scale, to millions of users, and no one really likes creating, sign in and sign out and all that, nonsense that you've got to deal with, and adding password policies and social identity providers, where with Cognito you can add social identity providers, so SAML, so SAML, or IDC, based entity providers, which we've been using quite a lot recently. And it just takes away the mundane, repetitive sign in, register, it takes that off your hands. And of course, because this is AWS, it deals with all the compliance standards, identity standards, so OAuth 2.0, OpenID Connect, SAML 2.0, integrates with front end and back end nicely. There's a bunch of SDKs around for this too. Cognito also, I believe, provides a built-in and customizable UI for signing. I think it's for the sign up and sign in. It does both, and you can use iOS, Android, JavaScript SDKs for this. And I'm sure there's ones out there for Python and .NET because it's a very, very popular service. So it makes it very easy to handle the sign in and sign up for your apps. And users can verify as well. Like AWS does provide SMS, and we can see here on the resources. You do have API gateway, other resources available. You could hook into other resources like for SNS if you wanted to, or something where you can actually provide users with an SMS or a one-time password. Furthermore, I guess we're coming to the end of this now. You can also use Google Authenticator and other authentication apps. I imagine you can use LastPass, 1Password, those sorts of password managers to do two-factor authentication. I think most of them have it now. And of course, because it's an API, it's just got a bunch of work behind it. It can work in conjunction with a WAF, which is a web application firewall, which we didn't really touch on. But hopefully the majority of people understand what a WAF is. If not, I'll try to cover it. Amazon Cognito offers great bot detection too. So you get all those features out of the box, and you can help save your organization from paying for automated accounts. Right, so that's all the services. One thing I want to touch on right now is the 3-tier architecture. And if you haven't come across this, this is just, I guess, a one more thing at the end of this that I really want to add. So if you haven't come across it and you're thinking about creating an architecture for a front end and a back end and a database, this is a well-established software application architecture that organizes applications into 3 logical and physical computing tiers. So you have the presentation tier, the application tier, and the data tier. Presentation tier, as you can imagine, user interface, application tier where the data is processed, so this could be your back end, the data tier where the data is stored and managed. So 3 tiers in detail. So most of the 3-tier applications are targets for modernization, cloud native technologies, containers, microservices, serverless, lambdas, all these buzzwords that are flying around on all these cloud architecture blogs and whatnot. But if we take a look at the presentation tier, right? So the presentation tier, as mentioned, user interface, communication layer of the application where end users interact, they input things, they navigate around, and this is where all this is living on the presentation tier, right? Whether you're using React, Vue, .NET, I can't remember what's the front end for .NET called. Razor Pages, I think it is. Maybe, I don't know. But yeah, this is a top level tier that can run on a web browser, desktop, graphical user interface. This is, I guess, what you would see. To put it simply, it's what the user interacts with. Presentation tiers for the web, as you can imagine, HTML, CSS, JavaScript, and desktop applications can be written in a variety of different languages these days, even JavaScript. Application tier, known as a logic tier or middle tier, is the heart of the application. So in this tier, information is collected from the presentation tier, or where it's been processed, right? So in the presentation tier, sometimes against information in the data tier, so you can be using business logic, specific set of business roles, and the application tier can add, delete, or modify data in the data tier, right? So this could be an API, potentially, or could it? Because what you got to think is when you get to that second tier, which is the application tier, it's at a point where, you could set maybe this could be, Lambda if you wish, right? And you can communicate from here, the application tier, to the data tier, which is where all your data is living, and then you can do your modifications there. But this is where all the business logic's living, right in here. So the application tier is typically developed with Python, Java, Perl, blah blah, all these other languages, PHP, Ruby, and it communicates with the data tier using API calls. So you cannot access it directly. So let's look at the data tier. So the data tier is sometimes called the database tier, the data access tier, or backend, where information is processed and the application is stored and managed. This can be a relational database management system or a NoSQL database server. In a free tier application, all communication goes through the application tier, which is the second tier that we just touched on. The presentation tier and the data tier cannot communicate directly with one another. I take it back what I just said. So the application tier can communicate with the data tier, but the data tier cannot, well, the presentation tier cannot directly talk to the data tier. And that's where you get your application tier sat right here in the middle. And you will probably see this, like, let's say, if you can try and imagine you have a VPC and you have 3 different subnets. You have presentation tier, application tier, data tier, and then you lock those down accordingly. And this is how it looks, basically: presentation tier, application tier, and data tier. And that's pretty much it. I'll take a final sip after that long presentation. Now, yeah, that was fairly long. There was a lot in there, so do try digest it. A lot of the stuff was just from high level, but there was a lot in there where I don't know, hopefully it could be useful for the developers. Yeah, so there was a lot in there. A lot of the nuances that you will come across probably weren't mentioned in this presentation. And just for reference, if we go all the way back, there's 200 plus services in AWS, and there's a bunch here that I mentioned that I really like. Now, always check the documentation. Like, nobody's going to know, even if you was a fully cloud certified engineer, you're not going to know all 200 services. I think it's quite impossible because new stuff's just getting added all the time. But yeah, generally what I do, I get interested in one of the services. I Google, read up about it, read the AWS documentation, try play around with the SDKs. Playing around with the SDKs was one of the ways that I started collecting knowledge, I guess, around AWS, because you're interacting, fairly directly with that service, as opposed to if you're using the console. I don't know, I always find, I wouldn't say I find it harder in the console, but I find it easier when I'm doing the code to interact with AWS. But yeah, hopefully it was helpful. There was a lot we went over. I can only imagine there's some parts that you might have to just research, but that's programming, that's architecture, that's cloud, that's serverless, that's, it's just trying to get to a point where you can understand this stuff more in detail. If one of these services piqued your fancy, go ahead and Google it, find out more. Like I said, I only gave a high level overall for this, but if you did find it useful, that's decent. Whistle stop tour of AWS services. These are some of the essentials. If we was being truthful, there probably would be another 20 other services if you're doing actually probably not 20, maybe 10. But if in doubt and you're just building a front end, a back end, look at SQS, look at potentially EC2, Fargate, ECS. And if you set it up just using the free tier model or architecture, you should be good. Trying to think if there's anything missed. I guess the final thing just on this data tier, more than likely online you'll see like differences between tiers or layers in the discussions of like 3-tier architecture. Layer, I guess, or tier is often interchangeably used and mistakenly, I guess, for tier. And I don't know, when I've read up about this stuff, I've always interpreted it as tiers. So like I guess the presentation tier, or if we're talking about the business logic tier. But if we are talking tiers, and then if we'll be asking, okay, well, what are layers? It's just a functional division of the software, right? So the functional side of it. But yeah, I wish I probably should have done a model of this, but if you can imagine, like here, this is wrapped in a VPC. You have a subnet here, subnet here, subnet here. I would make this one private, and then only allow communication probably from here, the application tier. Now, if you try communicating from the presentation tier to the data tier, I wouldn't allow that. And you've got an ample amount of opportunities to lock that down. You can use security groups, and then you can make it basically into a private subnet. And then depending on how you want to go from that. But if, like I said, if you look online at the 3-tier architecture, there should be, and just type AWS after, should see some architecture diagrams on that. But anyways, hopefully that was helpful. I'm rambling. It's very late. Yeah, that's it. I'll see you later. Good night.